Okay, let's move on. M18, 2014. Question 2. So, let A and B be root numbers. Consider the cubic equation. X cubed plus 2bx squared minus a squared x minus b squared equals 0. Alright, cool. Show that if x equals to 1 is a solution of star, then this holds. Okay, interesting. Well, if x equals to 1 is a solution, well, chuck that in, right? I think that's intuitive, right? That's instinct. So, 1 plus 2b minus a squared minus b squared equals to 0. Okay, then what have we got? So, I want something only in terms of b, right? So, what would be a sensible thing to do? So, perhaps get everything with b to one side, right? That's sensible. So, let's go. So, b squared, let's go something like, how should we do this? Let's go 1 plus 2b minus b squared equals a squared. Good. Okay, now I have to get rid of the a. What do I know about a squared? Greater or equal to 0, right? Greater or equal to 0. So this thing is greater or equal to 0. Okay, i.e. what? i.e. 0 is greater or equal to b squared minus 2b minus 1. And then we can solve this, right? We can solve this easily. We definitely know how to do these things, right? Like that. And I have, 0 here. 2 greater or equal to, and so on, right? And so on. I'm not going to finish the rest. You know, it's obvious that we'll get this thing. Okay. Part 2. Show that there's no value of b for which x equals to 1 is a repeated root of star. Okay, so I want to find the roots. How do I find the roots of a polynomial? What's the sensible thing to do? Factorize, right? Factorize. Okay, so I know that x equals to 1 solution. Okay, let's do some division here. So I have x squared. So what do I need for x? Now, I have subtracted 1 here, and I need 2b more, right? I've subtracted 1, and I need 2b more. Okay, so I need to add 2b plus 1 of x. Right, I have to compensate for the minus 1, and I need 2b more. Okay, good. Now, what next then? So I need, what do I need? So, so I need minus a squared now. Okay, but I've already subtracted 2b plus 1 here, right? So I need to compensate. I need to compensate for the 2b plus 1, and I need to subtract the a squared. Yeah? Equals to 0. Yeah? Equals 0. Okay, so what happens? So this thing is equal to this minus b squared thingy, essentially, right? So let's suppose that it is minus b squared actually, or plus b squared, I suppose. Okay, now I need x equals to 1 to be a repeated root. What does that mean? That means that this bit here has an x minus 1 factor as well. Right? Okay, let's try to chuck in 1. So if 1 is the solution to this thing, then I have 1 plus 2b plus 1 plus b squared equals to 0. Right? Okay, but what does the left hand side factorize to? B plus 1 squared plus 1 equals to 0. Is that possible? No, right? Because b plus 1 squared is greater or equal to 0, and you're adding 1, even bigger. How could it hit 0, right? Never. Okay, so that proves that there's no value of b for which x equals to 1 is a repeated root of star. Yeah, convinced? Okay, now part 3. Given that x equals to 1 is a solution, find the value of b for which star has a repeated root. Okay, has a repeated root, right? That means that, now we know that x equals to 1 cannot be the repeated root from part 2. That's really important, right? So I need this quadratic behind to do what? To have only one solution. Okay, if I wanted to have only one solution, then what do? I take the delta, right? I take delta, or discriminant, whatever it's called, equals to b squared minus 4ac. Yeah, this has to be equal to 0. Okay, then now you could solve it, right? Then now you could solve it. It's not even a quadratic equation because the 4b squareds cancel actually, and you have 4b plus 1 equals to 0. What is it? B equals to minus a quarter, right? And what now? So for this value of b, does the cubic have a maximum or minimum at its repeated root? Okay, interesting question actually. So, firstly, what is the repeated root? Okay, let's sub in b equals to minus a quarter and see what actually is the repeated root. So this thing becomes x squared, and what, plus a half x plus 1 over 16, is it? Equals to 0, yes. And this becomes x plus a quarter or squared. Yeah? Okay, so minus a quarter is indeed, what is it called? Minus a quarter is actually the root. Okay, so how does the cubic look like? The cubic looks like that, right? So this has to be minus a quarter, we agree? Has to be, right? Because this is repeated. The axis has to be here, right? And this one has to be the 1. Right? Suppose if you think the minus a quarter is here, well then that makes no sense, right? Because the 1 would be here. 1 is not smaller than minus a quarter, right? So what is minus a quarter? Has to be a maximum. Has to be a maximum. Okay, so sometimes drawing a picture helps. Yeah, I mean obviously in the exam I suppose you need to be more elaborate and explain yourself in words, which is slightly more tricky, I suppose. Yeah, but the picture intuition should be fine. Yeah, you should be able to write the whole thing down neatly. Okay, cool. I mean these questions 2s in the early years are still manageable, right? Normally, yeah. The more recent question 2s are slightly more challenging. We'll get to those in a bit.